Before Aditya-L1 mission, 22 solar probe missions have already been launched, and now Aditya-L1 is the 23rd solar probe mission who will study the sun, and this is launched by Indian Space Agency, that is ISRO. Before going into detail, first we have to know and understand about the sun. As we know that the sun is the huge glowing sphere of hot gas. The sun is mostly composed of the hydrogen and helium elements. By mass, the composition of the sun is 92% hydrogen and 7.9% helium, and various metals make up less than 0.1% of the mass of the sun. And the sun shines because the hydrogen turns into helium by the process of nuclear fusion in its extremely hot core. Sun is a star and all the stars have an almost similar configurations. Sun, which is at the center of our solar system from billions of years ago until today, and it turns of celestial body like our planet and other objects orbiting around it. Sun is the main source of energy to all these bodies, including our planet Earth. If there is life exists in Earth, then it is only possible by the sun. If we talk about the exact distance of the sun from our planet Earth, then it varies with its position and its orbit because of the elliptical orbit. The average distance of the sun from our planet Earth is about 150 million kilometers, and this distance is called 1 astronomical unit. If we talk about the shape of the sun, it has been said that the sun is very round and it is not flattened on the poles like planet Earth, but it might be a deviation in its roundness, but it is difficult to measure any deviations in that roundness. And if I talk about the size of the sun, the diameters of the sun is about 1.3927 million kilometers. If you compare it with Earth's diameter, which is 12,756 kilometers in equator, the diameters of the sun is about 109 times that of Earth's diameters, and the sun is 3 lakh times as massive as Earth. Primarily, there are three layers that make up the atmosphere of the sun, and these are the core, the radiative zone, and the convective zone, and these are the internal part of the sun. Core is the centermost part of the sun. In this part, the hydrogen turns into helium through the nuclear fusion reaction, and the temperature of the region is believed to be more than 15 million degrees Celsius, and the hottest part as well. The next layer from the center, that is radiative zone, and radiative zone is the layer which transmits energy towards outside by means of radiative diffusions and thermal conduction. Energy travels through the radiative zone in the form of electromagnetic radiation as photons. Convective zone is the outermost layer of the sun's interior. Energy is primarily or partially transported by convective mode in this region. The temperature of this region is about 2 million degrees Celsius, and the outer atmosphere of the sun is made of 6 layers. These are the external structure of the sun, which starts after the convective zone. The first layer, that is photosphere, and this is the surface of the sun. The meaning of photosphere is sphere of light. The glowing ball that we can see in the sky is the photosphere, and the surface of the sun is the only part we can see from Earth on a typical day without using of specialized equipment, and the temperature of the photosphere is about 5500 degrees centigrade. It is said to be the coolest part of the sun because with an increasing height the temperature gets dropped. The second layer of the outer atmosphere is the sunspots. The phenomena of sunspots happens in the photosphere. Sunspots are the basically dark spots, and this happens because the regions becomes darker and cooler than the surroundings due to intense magnetic field on the surface, and it fluctuates from a few days to a few months. The third layer, that is chromosphere. Chromosphere is visible as a dim red ring, and it lies just above the photosphere. It can be seen only during the solar eclipses when the photosphere is hidden. The fourth layer, that is corona. The corona layer is the outermost layer of the sun's atmosphere, and it can be seen as a white glowing corona. Solar wind and solar flares kind of phenomenon are related to corona layer. The next is solar flares. Sometimes sudden, rapid and intense variation in brightness is seen on the sun, that is solar flare. A solar flare occurs when the magnetic energy that has built up in the solar atmosphere is suddenly released. Basically, solar flares are the explosion of released energy. energy. At the last, there is solar wind. The solar wind is a stream or flow of energized charged particles which are primarily electrons and protons flowing outward from the sun through the solar system at a very high speed, and this is made of plasma. Now the question is here that why should we need to explore the sun? And the answer of this question is that the sun's gravity holds the solar system together. It keeps everything from biggest planet to the smallest particle of debris in its orbit because of its gravitational power. The interaction between the sun and earth drive the seasons, ocean currents, weather, climate, radiation belts and auroras. Human beings have always looked upon the sun as the most important celestial body. Even the primitive people realized that the light and the heat from the sun sustains all life on earth. They knew that any disturbance to the sun's daily motion through the sky would have serious effects. Over the years, they performed many rituals to ensure the reliability of sun. Slowly, scientific exploration towards sun has been started. Firstly, the Greek philosophers explored about the motions of the sun. Then after the invention of telescope, Galileo proved that sunspots mere true makings or structure on the surface of sun. And now many space agencies of different countries has been started exploring about the nature of the sun by sending space missions, particularly the solar probe mission to study the nature of sun. Europe, United States of America, Japan, China's space agency have launched such missions to study the sun previously. Parker Solar Probe, a solar mission which was launched by NASA in 2018. Till date, the Parker Solar Probe has become the fastest human-made object ever recorded. This is approaching the sun with a blistering speed of 6,35,266 kilometers per hour. At the same time, the probe set a new distance record, swooping within just 4.51 million miles of the solar surface, closer than any spacecraft has ever orbited before, according to NASA. Parker Solar Space Probe is a 7-year mission to understand the sun's corona, or the outermost layer of the sun's atmosphere. To understand that how heat moves through the corona, how plasma and magnetic field change on the sun's surface, and how that powers phenomena such as solar wind will help scientists better predict space weather, according to NASA. After the success of Mars mission and Chandrayaan-3, ISRO took another giant step in the field of space science, and this time ISRO launched a space mission in the name of Aditya-L1 mission, which was launched on 2nd September 2023. Here Aditya is a Sanskrit meaning of sun and L1 denote the Lagrange point. Basically, Lagrange points are such position in the space between the two masses where the gravitational attraction of two celestial bodies cancel out each other's gravitational pull. This can be used by spacecraft to reduce fuel consumption needed to remain in position. There are 5 Lagrange points around major bodies such as planet or a star. These points are named after Joseph Louis Lagrange, who was an 18th century mathematician. 3 points of them lie along the line connecting the two large bodies, and 2 of them are opposite to each other. The distance of Lagrange point L1 between the Earth and the Sun is 1.5 million kilometers away from Earth, which is about 4 times farther from Earth than the Moon. The estimate budget that has been allocated for ISRO Aditya-L1 mission is 400 crore rupees. Now the first objective of this mission is to observe the dynamics of the sun's chromosphere and corona, where it will study chromospheric and coronal heating, the physics of partially ionized plasma and coronal mass injection and their origins, and the coronal magnetic field and the transfer mechanism and flare exchanges. And the second objective of this mission is to observe the physical particle environment and its position. And the third objective of this mission is to determine the sequence of process in multiple layers below the corona that lead to solar eruptions. And the next objectives of this mission is to study space weather and the origin, composition and dynamics of solar wind. Aditya-L1 is carrying 7 payloads, and the first, that is VELC, which is known as Visible Emissions Line Coronagraph. It will study the solar corona and will observe the dynamics of coronal mass injection. And the second payload, that is SUIT, which is known as Solar Ultraviolet Imaging Telescope, and it will capture the images of the solar photosphere and chromosphere in near ultraviolet, and it will measure solar irradiance variation in near ultraviolet. And the third payload, payload, that is SOLEXS, which is known as Solar Low Energy X-ray Spectrometer. It functions as a soft X-ray spectrometer. It will study X-ray flares from the suns across a wide X-ray energy range. The fourth payload, that is LEL1 OS, which is known as High Energy L1 Orbiting X-ray Spectrometer, and it acts as a hard X-ray energy range. And the fifth payload, that is ASPEX, which is known as Aditya Solar Wind Particle Experiment, and it will study the solar wind and energy ions and analyze their energy distribution. And the sixth payload, that is PAPA, which is known as Plasma Analyzer Package for Aditya. It will gather data on plasma characteristics and compositions in the interplanetary space. It will provide insight into solar wind interactions with the environment. And the last and seventh payload, that is MAG, which is known as Advanced Triaxial High Resolution Digital Magnetometers. It will measure the low intensity interplanetary magnetic field in the space, and it has two sets of magnetic sensors, one at the top of a 6-meter deployable boom and the other is the middle of the boom 3 meters away from the spacecraft. And now at this point, one question that has been arises in the mind of many people is that how will India's first solar mission, that is Aditya-L1 spacecraft, survive the sun's heat, and will it not burn up? And the answer is very simple here, is that Aditya-L1 spacecraft will not burn up in the sun's heat because it will not actually be going into the sun. It will be placed in a halo orbit around the Sun-Earth L1 Lagrange point, which is located about 1.5 million kilometers from the Earth and 148.5 million kilometers from the sun. This puts Aditya-L1 at a mere 1% of the Sun-Earth distance. The sun's heat is still very intense at this distance, but Aditya-L1 spacecraft will be protected by a heat shield made by a special material called MLI, which means multi-layer insulation, and the MLI will reflect most of the sun's heat away from a spacecraft and keeping it cool enough to operate. Now the question is here that what are the significance of this mission? And the first, that is, as we know that the sun is at the center of our solar system and its characteristics greatly influence the behavior of all other celestial bodies, and studying the sun enhances our understanding of dynamics of our solar neighborhood. And the second, that is, solar activities such as solar flares and coronal mass injections can impact Earth's space environment, and understanding these phenomena is crucial for predicting and mitigating potential disruptions to communication system, navigation, and power grids. And the third is that exploring the sun's complex behavior, including its magnetic field, heating mechanism, and plasma dynamic, contributes to advance in fundamental physics and astrophysics. And the next, that is, the sun is a natural fusion reactor, and insights gained from studying its core and nuclear reactions can inform our pursuit of clean and sustainable fusion energy on Earth. And the next, that is, solar radiation and solar wind affect the functioning of satellites and spacecraft, and understanding these solar interactions allow for better spacecraft design and operation. And with this success, it will boost up the morale of ISRO and its scientists and India as well.